in which the customer used 326 minutes was not actually that customer's phone. That's a problem. That particular month, the customer did not use their phone at all. So 0 minutes were used. How does changing the observation from 320 to 0, 326 to 0? In other words, we're going to change this data to 0. Okay, how does it affect the standard deviation and interquartile range? What property does this illustrate? Okay, so data is already my calculator. So I'm going to pull the calculator up and I am going to change the number 326 to 0. Let's see how it will affect the data. So I'm going to change the number 326 to 0. 326 to 0. Okay, and then I hit enter. And I would do one variable stat of this data and see. Make sure we do it again. The other day we started this. So I'm going to do 326 right here now. And hit enter. So I'm going to do one variable stat of this data. So I'm going to go to stat, arrow to calc, and do one variable stat of the data in L3. That data is in L3. It is not a group data. So I'm going to calculate. So the mean of that data is 406.25, round to 2 decimal places. So 416.25 is the mean, and the standard deviation of the sample is 78.4. So the standard deviation is 78.42. 78.42. And I'm going to get my whiteboard because this is not cooperating. So 78, the mean, the standard deviation of data is 78.42, and we're also to find the interquartile range. So if I did one variable stat, I know the interquartile range. So I'm going to go back and find the interquartile range. If I arrow down, I see all the quartiles. The interquartile range is Q3 minus Q1. So Q3 minus Q1. And that is the same as, I'm going to go back to my calculator. So Q3 is 486. 486. And what is Q1? Q1 is 342.5. 342.5. Now we want to find the change. What is the IQR? So I will just find the IQR by, I will quickly go to my calculator, even though I know from here now that IQR should be, if I take away 0.5 here, so actually I have 0.5, so 3.5. Altogether, I have 43.5, but let me make sure with my calculator. Okay, so I have 486 minus 342.5, so 486 minus 342.5, and then I'll get an answer, and my answer is 143.5. So that is the IQR, and I'm going to write it down because we are going to compare. So IQR is 143.5. And the IQR of the original data is 143.5. And the standard deviation of the original data, well, but now the student actually did not use his data. He used somebody's data. So I'm going to go to 336 and put in 0 because we found out that he only used 0 because he wasn't using his phone. So this is 0, enter. Now I'm going to calculate again one variable size of this data. One variable that start of the data, replacing 326 with 0. So let's see how it affects this reduction. Let's see how it affects the original data. And so I'll just do stat, calc, one variable stat of the same data in L3, except that 326 was exchanged with 0. All right, so the new standard deviation is a whopping 120.7. So 120.7. 120.7 is a new standard deviation. Standard deviation 2. Standard deviation 1. Well, so let's go down and see so what is the interquartile range? 486 minus 342.5. It's going to be the same thing. So the interquartile range is 143.5 IQR. So IQR actually did not change. What changed is the standard deviation. So the standard deviation changed. The standard deviation changed immensely. So if we go up again, we see the standard deviation, and that standard deviation changed from 78.42 to 120.7. Therefore, reduction, changing, or introducing a data in a raw data affects the standard deviation a whole lot. So it affects the standard deviation more than it did to interquartile range. Okay, so we have answered this question, which is in a practice test. So what property does this illustrate? Choose the correct answer. So we put the standard deviation and the interquartile range here. It changed the dispersion. The dispersion changed. It enlarged the standard deviation. It changed the dispersion. Okay. Question. Let's make sure we already know how to do after giving a statistics exam. Professor Dang determined the following 5-number summary. Use this information to draw a box plot. So the maximum number in that data is 98. So maximum number is 98, approximately 98. I am going to make my own sketch a little bit somewhere here. All right. And I'm cleaning everything in the question here. So I'm using Professor Dang's 5-number summary to draw a box plot. I'm using Professor Dang's 5-number summary to draw a box plot. All right. The maximum number is 98. The minimum number is 60. The first quartile is 68. The third quartile is 89. The median is 77. Okay. And let me see which one actually. So I can just, if I don't understand the box plot, I will draw my own box plot. 77 is the median. So let me see. It is not this box plot because the median is 77. Okay. It's not this box plot because it's actually more. I think the actual box plot should be A. But if I advise you to make sure that if you don't really understand the box plot, you draw your own box plot. You draw your own box plot. Okay. Now about z-score. Number 4 is about z-score. So you just have to be careful. The first thing I want to remember is the formula for z-score. So z-score, the formula for z-score is value minus mean over standard deviation. Value minus mean over standard deviation. Therefore, you must be given standard deviation. I want to just take the z-score here as for it is from a number distribution. So value which is x minus the mean of the data over standard deviation. Well, I'm going to call it the standard deviation of the population. So that way. Okay. We don't know whether it's a population, but let's assume it's a population. Suppose babies born after gestation period of 32 weeks to 35 weeks have a mean weight of 27. Let's write it down. Babies born after they have been in their mommy's tummy for between 32 to 35 weeks, they weigh 2,700 grams. That's what this question says. And the standard deviation is 900 grams. So standard deviation of this is 900 grams. And then that's another question. So we know we are comparing. It is about z-score. Okay, so after 40 weeks, they have a mean score. So let's see what the next question says. 900 grams. While baby is born after gestation of 40 weeks. So if a mom carries a baby in the stomach, if the baby stays 40 weeks or more in the stomach, 40 weeks or more in the stomach. So this question is saying that we need to find the z-score. Of course, you cannot compare the babies because you need to know the z-score. You can't compare the babies because you need to know the z-score. Okay, so, and baby is born after 40 weeks, while baby is born after a gestation of 40 weeks, which means the one that stays for 40 weeks or more in their mommy's tummy have a mean weight of, so their mean 40 weeks and above and greater has a mean weight of 300,000, or well, 300 grams, which is 3,000, oh, that's 3,000 grams. So 3,000 grams and a standard deviation of 404. Standard deviation of babies that stay more than 40 weeks in the stomach have a standard deviation of 455. Okay, the question here is, if a 33-week gestation period baby weighs 3,000 and a 40-week gestation baby weighs 3,400, find the z-score. So we have to take it easy because now we know that they're asking us of two different things, apples and oranges. We cannot compare until we find the z-score. So we're going to find the z-score. Let's call this one A. We're going to find the z-score of A, find the z-score of B. Okay, so z-score of A, we already know that is value minus mean times divided by standard deviation. Okay, so I am about to, all right, so for the first one, I am going to do it on top so the first one is all going to be here, and we'll get the information for the first one. And then suppose the baby born within 3 weeks period weighs 3,000. So the Z for this is value. The value is 3,000. And then the mean is 2,700. And the standard deviation is 900. And then we call this one ZA. Okay, and then we shall call this one ZB. Okay, so let's see what's and now the babies born after 40 weeks, they weigh 3,300 grams. Find the corresponding Z scores. So the one that weighs that stays more than 40 weeks in the stomach, in the weighs 3,300. So I'm going to have the value 3,300 minus the mean. The mean right here is 3,000, according to the information given to us, divided by standard deviation 455. Okay, so these are all the information given to us. We have to standardize the babies that stayed in the stomach for 33 weeks and baby that stayed in the stomach for 40 weeks. And we find their z-scores. And after we find the z-score, the question is, which baby weighs more? Which baby weighs more relative to the gestation period? Which baby weighs more? Okay, so now I'm going to find the z-score for the first one. I'm going to pull my calculator up. So z-score for the babies that stay in the stomach for 33 weeks. So I have 3,000 minus 2,700 is 300. So I got 300 divided by standard deviation. The standard deviation is 900. And if I see that, I notice it is 0.3 or 1/3. So this z-score here is 1/3 or 0.3, 1/3 or 0.3333. Okay, and then let's find the z-score for the second one, ZB, and that z-score is 3,300 minus 300. And this is the same as 300 again divided by the standard deviation. The standard deviation of babies that stay 40 weeks or more, because they are different. So for 55, when I divide, I have 0.6. Let me know to how many decimal places. So the z-score here is 0.66 approximately. So the z-score here is 0.66, while the z-score here is 0.33. Therefore, the babies that stay more than 40 weeks, okay, has the higher z-score. The babies that stay more, which baby weigh more? So the babies that weigh more are the ones that stay more in the stomach, the ones that stayed 40 weeks in the stomach. Actually, they weighed 0.6, 0.66. They weighed twice. They weighed twice because 0.66 multiplied by divided by 2 is 0.33. So actually, babies that stay full term, the babies that stay in the stomach full term, they weigh more. Okay, the babies that stay full term, they weigh more. If the baby is premature, the baby will not weigh as much. Okay, so that's question. The question is about empirical. Well, it's about z-score property normal distribution. One of the properties of normal distribution is z-score empirical rule. The normal curve is symmetrical about the mean. Area under the normal curve is 1. The mean divides the normal curve into 2 equal parts, 50-50. So we already know that. All right. I'm not going straight one by one because actually there are some more important things that we have to talk about. Let's talk about the grouped data, because we said that group data is important to know. All right. Anyway, let's talk about group data, and I'll come back here. Actually, well, let's come over here. So as we go down, we have to get to group data today. Make sure we review it again. We want to make sure we review group data again. If you look at number 1, it says we are told to find the sample. Number 7, we're told to find sample standard deviation. I just want to make sure you know what to do. Put the data in your L1. Put the data in your L1. Find one variable start of that data and find the sample standard deviation, square it. So I can just quickly do that. So let me quickly do that. So I am going to put this data in L1. I will clear whatever is in my L1. I don't need it today. Clear, enter. So the sample data, how do I know it's a sample? How do I know it's a sample? I am told to find the sample variance. So that's how I know it's a sample. Because it's a sample, the sample variance has to be S squared. That's all. That's all. Okay, so I'm going to put the data in. 18, 18, enter 13, 6, 10, and 8. So this is the data. There are only 5 of them, and I'm told to find the variance of the data. All right, so I am going to do one variable start. Go to start, one variable start of this data. The data is in L1, so be careful. So you tell your calculator that data is in L1. I don't have frequency list because it's not a group data. Okay, so I'm going to calculate. And I'm not asked about sample mean, so I will not worry about sample mean, but I'm told to find sample standard deviation. The sample standard deviation to 2 decimal places is 4.7 approximately. The sample standard deviation is 4.7, but I'm not. Okay, so I'm just going to put 4.7 in the sample standard deviation here, 4.7. Sample standard deviation is 4.7. Now I am told to find the sample variance. I am not going to square this. Go back to my calculator, and I will square a 9-digit sample standard deviation. How do I do that? Last class, I showed you that you can go to variance, statistic, okay, and variance statistics. So when you get there, you're looking for sample standard deviation, which is number 3. Sample standard deviation is number 3. So when I square it, if I hit enter, actually, it gives me the 9-digit standard deviation. So I know that I'm not truncating it. Then I square it, I have 22. Therefore, the variance of the data in number 7 is 22. The variance of the sample is 20. Because data, I put the data in L1. I put the data in L1, and it's asking me about frequency. I don't have frequency because it's not a group data. After this now, we shall do the one that has frequency. Okay, and then I go to calculate. So when I calculate the one variable start, the question is find the sample standard deviation. The sample standard deviation is S sub X, this one. The population standard deviation is sigma X. So the sample standard deviation is approximately 7, because I'm told to round my answer to 1 decimal point. So that is 4.7. So sample standard deviation is 4.7. Remember, so this is sample standard deviation. This right here is sample standard deviation. So you have to put the answer here, 4.7. 4.7 has to be there because it is the sample standard deviation. Okay, so you got the sample standard deviation. The next one is find the sample variance. The best way to find the sample variance is to copy down all the digits in. So I will just copy down all the digits. Make sure the 9 digits. If you like, you can copy it down on your paper. 4.6901441579 and square it. If you don't know, if alternatively, you can go to VARS statistic, and because your calculator stores the statistics of every one variable stat you just did, it's number 3. VARS statistics is number 3. So you put in number 3 there. So you ask your calculator to give you number 3. And then you enter. That is exactly what the standard deviation is. But you are looking for variance. And you know that the variance is the square of standard deviation. So you square the standard deviation and enter. That is the variance. So that's what we get. Is it clearer to you now? Is it clear?
Yes.
Okay. Okay. So if you are told that this is a sample,
Mm-hmm.
well, sometimes if they don't tell you it's a sample, for example, this one, they already told it's a population. And they told you to find the mean and standard deviation. So when you finish, you change this, whatever the mean. Okay, I will do it because, let me do this. I want to do it because I want to make sure you understand. Okay, so I'll go to start again under L1. I'll clear L1. Or maybe let me go to L2. I'll clear L2, clear enter. Okay, and then I'm going to put this data in L2. So 2, 9, 16, 14, and 9. Okay. And then I'm told to find the mean this time. And the mean that I'm told to find is mu, because this is a population. So the mean is A, population mean, mu. That's what I'm looking for. So I'll quickly do one variable start of L2. So I go to start, calc, one variable start of L2, second L2, because the data is in L2, and then I'm going to calculate. Okay, the mean is 10, but you must answer the question. You must put the data here. So your answer has to be in this box, 10. Even though it is 10 for both, but 10 has to be in mu, the first box. So you put 10 here, 10. You put 10 there because somebody wants to know if you know how to answer, if you know the difference between the mu and x bar. Do you know your parameters and statistics? Okay, I hope that is clear. So this number 9 is like is the same as z-score we did before. So it's still z-score. The next number we're going to do before we want to make sure we get there is group data. Don't forget that relative frequency is frequency of one class over total frequency. Frequency of the class over total frequency is the relative frequency of it. Okay, so this is what we want. We want to do this because it's a group data. We want to make sure we remember this. So the first thing we want to do, I am going to actually write this data in my whiteboard. So let me write this data in my whiteboard. That way it is not, okay. So I want to write this group data. The first thing I want to do is make sure that the group data is standing up. Make it vertical. This group data is horizontal. Make it vertical. So the first class is 50 to 59. And the frequency is 3. I know we did it before, but that's not going to take anything if we do it again. The next class is 60 to 69. The frequency is 324. The next class is 70 to 79, and the frequency is 1499. And the next class is 80 to 89. So 89, and the frequency of that class is 15, 18. And the next class is 90 to 99, frequency is 271. This is 90 to 99, frequency is 271. And the last class is 100 to 109, frequency is 12. 100 to 109, and the frequency is 12. Okay. There could be so many questions here. The first question could be, what is the class weight? That could be, what is the class weight? So I'm going to write class here. This is classes or class. This is frequency. Okay. So I'm going to bring it down a little bit. So this is frequency. Frequency. All right. There could be so many questions here. They can ask you so many questions. They can first of all ask you, what is the class weight or class size? The class weight is the difference between consecutive lower limits. That's 60 minus 10 is 10. So class weight is 10. Class weight is equal to 10. The next thing will be find the total frequency. You can just do it with your calculator. And the next thing will be find the class midpoint. You could be told to find the class midpoint. Whether you're told to find the class midpoint or not, you should be able to find the class midpoint because the question wants you to find the mean and standard deviation. Find the mean and standard deviation. And also draw a histogram and so on. So it says find the mean standard deviation, draw a histogram, use the frequency histogram of the data to verify the distribution is bell-shaped. Okay, so is this distribution bell-shaped? I can just eyeball this and say maybe it's bell-shaped. But if I want to be accurate, I will compare the mean and the median. So, and then C, according to the empirical rule, 95% of data uh, lie within 2 standard deviations. So now I know that I will add mean plus 2 standard deviations to the right and put it here, and mean minus 2 standard deviations to the left. So that's not a big deal. Okay. All right. So the next thing I want to do now is I put this data here. So the next one is find the class midpoint for each class. The class midpoint is lower limit. Class midpoint is lower limit plus upper limit divided by 2 for each class. So I find the class midpoint of the first class, 50 lower limit plus 59 upper limit divided by 2. So if you add them, you have 109. 109 divided by 2 is 54.9. So the class midpoint for the first class is 54.9. Well, guess what? If I find the class midpoint of the second one is 60 plus 69 divided by 2, I will actually get 64.5. And the distance between these two is 10. So that tells me that the difference between consecutive class midpoints is 10, class weight. So 74.5, 94.5, because I know that the distance between them is 10, 104.5. So I have found all the class midpoints. I could be told to find relative frequency of all the classes, or I can be told to find the relative frequency of the first class. The relative frequency of the first class is frequency of the class 3 over the total frequency. And total frequency, I have to calculate that. But I just want to make sure we know the relative frequency of each class is frequency of that class over total. Okay, and I'm going to put the data in my list because my calculator will actually find all of them for me. Okay, so I will get my calculator and turn it on. And I'm going to clear and go to start, edit. And this is a group data, so I have to be careful this time. I'm going to go to L1 and clear L1. Clear L1. I will also clear L2. All right. The class in any group data, the class midpoint is always in L1 or the first class. That's the first thing you have to type in your calculator. So 54.5, 64.5. What am I doing? I'm typing the class midpoint. Each class midpoint is the class representative. 74.5, 84.5, 94.5, 100.5, 104, 104.5, 104.5, All right. Okay, so that's the last class midpoint. Now I will go to L2. This is a grouped data. Therefore, each class midpoint has a corresponding frequency. So the frequency of the first class is 3, followed by frequency of the second class, 324, followed by 1499, followed by 1518, followed by 271, followed by 12. So these are all I've typed in all the class midpoints in L2, class midpoints in L1, and I typed in the frequency in L2. I'm now ready to do the one variable start of a grouped data. We did it before, but we're doing it again because tomorrow the test starts on Thursday. Okay, so I'm going to go to Stat, arrow to Calc, and I'm about to tell my calculator where my class midpoint is. It's in L1, so I do second L1. You cannot forget to tell the class. Do second L2, and then calculate. Therefore, I have just calculated the one variable start. The question asked me to find let me go back to the question so we can figure out what the question is asking. What is it asking us to do? Let's see what the question is asking us to do. The question is asking us to find the mean and standard deviation. So let's get the mean and standard deviation. The mean of this data, the mean is, let me say, to 1 decimal point. I want to make sure round to 1 decimal point. I see, I'm making sure that it's 1 decimal point. So the mean to 1 decimal point of this data, according to my calculation, is, this is the mean here, 79.4 approximately. That's the mean. And we are told that this data is a population. Therefore, the standard deviation of this population is 7.8. The standard deviation is 7.8. The mean is 79.4. So mean, remember it is population. So you're writing mu, 79. The mu is 79.4. And the standard deviation is 7.8. Standard deviation is 7.8 approximately. This is what we are told to calculate. And then they asked us, is this data normally distributed? We can actually use a calculation right there. It looks like it's normally distributed. If you draw the histogram, okay, but I want to first of all find the median, because if I can find the median, I'll compare the median with the mean. When I compare the median with the mean, I will know if it's normally distributed, or can I just assume they are close to each other. The median is 74.5. So the median is 74.5. Q2 is 74.5. If the data is normally distributed, the mean and median are approximately equal. But the mean here and the median are not equal. But anyway, we shall approximate because they indirectly told us to approximate. Okay, so we found the mean, find the median, and now we want to assume that they are equal, even though it's a little bit skewed right. If the mean is greater than the median, data is skewed right slightly. Okay, anyway, So by empirical rule now, if I multiply the standard deviation by 2 and add it to the right, then I have the data on the right. If I multiply the standard deviation by 2 and subtract from the, so let me get my calculator and do it quickly. So we want to answer the question on, we want to answer the question about standard deviation, empirical rule. So answering this question about empirical rule, we want to make sure we remember that the data, 95% of data lie within 2 standard deviations. So because of that, we want to actually make sure we know that this point here is mu. This point here is mu plus 2 standard deviations. So let me just type it here. This point right here is mu plus, do you see? Plus 2 times standard deviation. 2 multiply standard deviation. Do you follow?
Yes.
Standard deviation. Okay. Okay, and then mean plus, because it is to the right. Here you are going to do mean minus, mean minus 2 standard deviation. That's what you're going to do. If you're calculating it, you just get your calculator. I'm going to put it in here. So we already know. I'm going to expand this now. And I'm going to grab this and move it up. So the data, I'm going to actually draw a normal curve also. I'm going to draw a normal curve. And I'm going to show that the mean is at the center. And that mean is 79.4. So approximately right here. So the mean is right here, 79.4. And somewhere here is 2 standard deviations above the mean. In other words, 79.4 plus 2 times 7.8 is the number that should be at the right. So let me find that number. Okay, I'm just going to find the number. And I have 79.4, 79.4 plus 2 multiply the standard deviation. Plus 2 multiply the standard deviation, which is 7.8. Okay, so the number to the right of the mean is 95. So we put this number 95 right here, approximately 95. Then I want the number 2 standard deviations below the mean. Okay, so I just have my calculator again. And I'm instead of adding here, I'll subtract. So I'm going to do second enter. So I am going to actually subtract instead of adding. So do negative, and if I hit enter, it's 63.8. Therefore, the number 2 standard deviations below the mean is 63.8. Therefore, the two numbers that are 95% of the data are from 63.8 to 95. 63.8 to 95 are 2 standard deviations above the mean and 2 standard deviations below the mean. Okay, so 95% of data lie within 2 standard deviations. So I hope this is easy. We have done it several times. And I'm going to stop here. So the review stops here.